Good afternoon, students. I will start with the class. Okay, so today's topic we'll be solving problems on higher order derivatives. Okay, so previously we had done derivatives where we were differentiating it only one times. So in higher order derivatives, we'll be differentiating it more than once. Okay, so consider if y is equal to any function of x. Okay, so what you get when you differentiate, what you'll get is dy by, so when you differentiate with respect to x, dy by dx will be, which will be same as f dash of x. Okay, so you are finding derivative of this function. If it was cos x, you would get minus sin x. So this is first time when you differentiate. Also can be written as y1, same as y1 means here. Okay, not up here. Y1 and this is called as first order. Okay, this is called first order derivative because only one time you have differentiated. First time you differentiated, you got this. Now again when you differentiate, the same thing, meaning first you had this, then you found a derivative, you got this answer. Now we are finding derivative of a derivative. Again when you are differentiating this answer, this will be second time you are differentiating. So what you will have to write is square. Okay, this 2 will be here upon dx square. So this is a standard way to write. Okay, 2 here on the numerator it is in the middle, and denominator it is at the outside power. Like this only you have to write. You cannot write like this. It will be completely wrong. So this 2. Okay, so this also called as double. Second time. Double time you have differentiated it. Also called as y2. And this is called as second order. And in this chapter, we'll be solving only on second order derivatives. Okay. Higher order derivatives and mostly I'll have only second order. If we had differentiated it another time, it will be going on continuing. So the third one would have been d cube y upon dx cube. 3 times. Also could be written as, and this would be third order. Okay. So first time when you differentiate, it is dy by dx. Second time you differentiate, it is d square y upon ds square. Third time will be this. Or you can write like this also, y1, y2, y3. Now we'll start with the problems. If y is equal to 3x raised to 4, find y3. Okay, the problem given is y is equal to 3x to x raised to 4. We have to find y3. Means we'll have to differentiate 3 times the same function. So first time if we differentiate, this will be y1, also called as dy by dx. Okay, whichever you all are comfortable, you can write. Now since they have given like this, you follow like. So first time when you differentiate, instead of dy by dx or y1 you can write is equal to, now derivative of this. This is a coefficient. X raised to 4 will be 4x cube. So answer will be 12x cube. This is simple.
72x.
Yes. So then we have found out only y1. So we'll have to differentiate it again. So y2. So y2, when you're differentiating, you have to differentiate the answer, not the question again. Huh? Here, from here you have to find the derivative. So this is already 12 and derivative of x cube will be 3x square. So answer will be 36x square. And then you have to differentiate third time because this is y3. So this will be 36 already there. Derivative of x square is 2x. So answer is 72x. Okay. Suppose if we had to differentiate it again y4, then it would become 72 and y5 would become 0. Okay. So this is how when you're asked to find higher order derivatives up till where it is expected, you have to go on differentiating. If y is equal to log 2x, find d square y upon dx square. So looking at this, you know it is second order, means 2 times you have to find a derivative. So first you differentiate, and whatever answer you get, you differentiate it again. So this is like this. So differentiating with respect to x. So first time they are using like this. So I can follow like this now. dy by dx is equal to derivative of log of something will be 1 upon that into derivative of 2x. Derivative of 2x will be 2. X and x will cancel. Okay, so what is left is 1 upon x. Now again you have to differentiate because second order has been asked. D square y upon dx square. So derivative of 1 by x I've already given in the table is nothing but minus 1 upon x square. Okay. If you forget this formula, still you can solve. 1 by x can be written as x raised to minus 1. Then using x raised to n formula, minus 1, x raised to minus 1. So it is nothing but 1 upon x square. So this is how you get derivative. Okay. So instead of this, if you remember, derivative of 1 by x is nothing but minus 1 upon x square. So this will be our answer. Can I attempt the third one? Same thing, find d square y upon dx square. Y is equal to 3 upon x plus 2 cot x. Anyone having doubt in the second problem can ask. Huh? Log x, I've differentiated it for the first time. Then again. For 12th standard, we have up till here only, second order. Okay. Cube and all, they will not ask. Mostly till here. So when you differentiate, get dy by dx 3. 3 is like a coefficient. 3 by x can be written as what? 3 into 1 by x. So derivative of 1 by x, just now I told you, is nothing but minus 1 upon x square. Okay. Plus 2 derivative of cot x is nothing but minus cos x square x. So this is your first order derivative. So what you'll get? Now for the next step you will need this x square, no, is at the denominator. There is no direct formula for 1 upon x square. So while writing, what you do is write it like this, x raised to minus 2. Anything at the denominator, take it up. This will be minus 2 cos x square x. So this is dy by dx. And now differentiate again to find d square y upon. Okay, even if you don't write like this, it's okay. Just find a second order. So this will be d square y upon dx square. This is standard, huh? Please do not interchange anything. Here, this square, here, anywhere. Here, middle, here, outside. Minus 3, x raised to minus 2 formula. X raised to n formula is what? N, x raised to n minus 1. 2. Now this is cosec square x. Cosec square x is nothing but like cosec x the whole square. Correct? It's like this. So derivative of x square would have been 2 cosec raised to 1x. Even if you don't write 1 is okay. Extra derivative of cosec x. So cosec x is nothing but minus cosec x cot x is the derivative of cosec x. Okay. So since this is square, first 2x into derivative of that x. Now simplify. So this will be minus into minus plus 6x raised to minus 3. Minus into minus will again give you plus 4. Cosec into cosec will give you cosec square. So this will be our answer. If you want, you can write like this as 6 upon x cube. Anyone having doubt in the third problem? I've taken derivative of first one.
So why that minus cosec into cot x?
See, this is like, what is derivative of cosec x minus cosec x cot x? Okay. This, if it was only cosec x, this would not be there. Answer would have been directly minus cosec x cot x. But there's a square term. So whenever there is a square, consider this like x square. So first derivative of x square is how much? 2x. This 2 is already at this side. Okay. Now this one's derivative x square is like 2x. But was it x? No. Extra derivative of cosec x. That is minus cosec x cot x. If you see the standard formula in the table, derivative of cosec x is this. Okay. Clear?
Yes, teacher.
From here onwards, you can expect these are like question paper type problems. Prove that. Okay, if y is equal to tan inverse x, prove that 1 plus x square into y2 plus 2x y1 is equal to 0. So if you know this now, by now you should know y2 means second order derivative and y1 is first order derivative. Okay, so you know that any function now you have to differentiate it 2 times because here 2 is a y2. So we'll take the first one. This is the main question which is given and we'll differentiate it for the first time. So when you differentiate, they have given in terms of these numbers. So follow that only. Don't write dy by dx. Instead of that, you can write it as y1. Okay. If they have used these numbers, you follow this. So y1. So derivative of tan inverse x is 1 upon 1 plus x square. Okay. Now remember this type problems when you're asked to prove something, what you do is always take this denominator other side. Don't complicate it. Instead of making u upon v and all, directly take it this side. So what will happen is, so you will get like this. Till you get it simple enough. What I did, first time I took the derivative and took this side. Okay. Now differentiate again because we have to find y2 also. So second time you have to differentiate. And now when you are differentiating second time, this is like u into v formula. This part is u and this is v. So follow u into v formula. So what is u into v? U into derivative of v plus v into derivative of u. So 1 plus x square into, see now already I have taken first time derivative. I tell you like this, if y, if you are differentiating, what you will get? Y1, correct? When you differentiate, you get y1. Y1, if you are differentiating, what you will get? Y2. Okay, so already this is y1. So u I've written as it is, derivative of y1 will be y2 plus v into derivative of u. V is what? Y1. Now derivative of 1 plus x square. So that will be 0 plus x square is what? 2x. So this is u into derivative of v plus v into derivative of u. Okay, and derivative of 1 will be 0. So I think you got the answer, what has been expected. 1 plus x square y2 plus 2x y1 is equal to 0. Anybody having doubt? First time I differentiated u into v. U write as it is, take the derivative of v. Already it is y1, so when you take another derivative, it will become y2. Then plus v write as it is, take the derivative of u. And this side derivative of 1 will be 0. Okay, same like first one. Only thing you will get in terms of root. Just have to square one term. That I'll show you. Fourth one, if anybody has doubt, please ask. Because now onwards we'll be solving similar types of problems only. So if you have not understood this, you will not understand the next problems. So y is equal to sine inverse x. So differentiate. So when you differentiate for the first time, y1 is equal to derivative of sine inverse is 1 upon root of 1 minus x square. So this is a standard derivative from the table. Okay. Now whenever there's a root sign, there's an option. Okay. If you want, even with root also you can solve, still you will get correct. In your college also they might directly differentiate also. But what I prefer is always take a square, because I don't want that 1 upon 2 root this and then cross multiply. So the moment I see root, I will square it. So squaring on both sides. So what will happen? This will become y1 square is equal to 1 square will be anyways 1 and root will go. So it will become 1 minus x square. And now multiply this side. So I've got rid of root sign. Those who want can do directly also. Take this side and start differentiating. Same answer you will get. Okay, now differentiate. Again, this is u and this is v. I'll write it that equation again here. This is what we have got. Okay. I'm writing this here. So differentiate. Now this is u and this is v. Now just see here, u into v I'm doing. 1 minus x square is your u. Right, it is it. Now we have to take derivative of this. See, now there's a whole square. Okay, so what you'll have to do is, this is like x square. So what is derivative of x square? Nothing but 2x. Same way, derivative of y1 square would be 2y1. Okay, and then extra derivative of y1 will give you y2. Okay, see how we were doing earlier. Y square is to be what? 2y into extra derivative is to write dy by dx. Correct? It means what? Dy by dx means y1. Same way, y1 square would give you 2y1 into derivative of y1 would be y2. Okay. So using that, I've done. So u into derivative of v plus v into derivative of u. 0 minus 2x. If this was only y1, no? If this was y1, straight away answer would have been just y2. Derivative of y1 would have been y2. But because there's a square, that's why it will be first 2y1 and raised to 1 into extra derivative. So 1 minus x square, 2y1 y2, minus will plus into minus. Now if you see, it is not matching with the answer, but there is something common in both the place. 2y1 is common. So what you do? Divide everything by 2y1. Okay, in this term 2y1 will go, y2 will remain. Same way 2 will go, 1y1 will go. So this is what you will get the answer. And that's what they had asked for. Anyone having doubt? This is only simplification part. This step you should understand. M cos inverse x, prove that one minus x square, this y2 and this. If y is equal to e raised to m cos inverse of x, prove that 1 minus x square into y2 minus xy1 is equal to m square y. So we'll take this, we say y is equal to e m cos inverse of x. So e raised to something, when you differentiate, it will be the same thing. So what you can do, directly differentiate with respect to x. So what this will become, y will become y1. E raised to something is e raised to same thing. But now this is not simple x. But this, instead of x, it is this. So you'll have to take extra derivative of whatever is there, the power. M is a coefficient. Coefficient means like some number. So don't do u into v for this. Simple m, okay. And what is derivative? Cos inverse x is. So this will be your answer. What I did, I took derivative of this. E raised to something is e raised to that into derivative of m cos inverse of this. So cos inverse derivative is this. Now you can just mark this as equation 1. Everything, if you notice, there is no e raised to anything left in the answer. So try to get rid of this. So if you notice, what is e m cos inverse of x? Nothing but y. So instead of that, next step, I will straight away write y. Okay, from equation 1. So minus m upon. So this is what you will get. And then you square because of this root sign. Squaring on both sides you do. If you want to know, you can write here and keep from 1. Now square, take this term on the other side and then start differentiating. So when you square, first of all, minus will go. So when you square, this will become y1 square. All will get squared now. Y square. Then minus m, the whole square will become plus m. Root will go and just become like this. Okay, this is when squaring both sides. You can write both sides here. Huh? So all the terms will get squared. And now take this 1 minus x square this side. So you will get like this. M square I write first. M square is nothing but a pure number. Okay, it's a coefficient. And now differentiate. Now same thing again. U into V. Same like previous problem. So whenever there's a square. So U into derivative of V. Square is there. So first what it will become? 2y1 into extra derivative of y1 will give you y2 plus v into derivative of u. 0 minus 2x is equal to m square is a coefficient into derivative of y square will be what now first? 2y into extra derivative will be y1. Same like this. Okay, because this was y1, it became y2. This is y, that's why it became y1. And now whatever is getting divided, you divide by the common term. I think 2y1 only you have to divide again. So this is nothing but to keep like this only, 1 minus x square, 2y1 y2 minus 2x y into y1. Common everywhere is 2y1. So divide all the terms by 2y1. 2y1 will go. Here 2 will go, 1y1 will go. 2 and y1 will go and only y will remain. So this is how you will get the answer. Still some doubt? Anyone? In this step especially? I've taken u into v, u into derivative of v plus v into derivative of u. Seventh one you all can try. That would be same thing. Y is equal to em sine inverse of x. Prove that answer will be same like cos 1. Yeah? This is for you all to try later on. If you all want, you leave space. Otherwise, you can try after the end of all the problems. Same like this one, it will end up. Only thing what had happened for cos inverse, it was minus, but after squaring it had become plus. So same steps you will get everywhere. Answer should be the same. Same like this sixth problem. Now we'll solve the eighth one. Y is equal to tan inverse x. Prove that 1 plus x square Okay, this is 2x minus m into y1 is equal to 0. So we'll start with the problem. And then differentiate. So this will be y1, same thing, e raised to m tan inverse x into derivative of m tan inverse of x. M into 1 upon 1 plus x square. Okay, now replace this. Instead of this, what will come? Y. One can write 1. From 1, this will be here. There is no need to square on both sides. Why? Because there is no root sign. So directly you take this side. Only for sine inverse, cos inverse, you will get that. Here tan inverse, it is not root. So don't simply this square. So directly take this here and start differentiating. And differentiate. This is u and this is v. This will be easy because there is no square term. Directly derivative of y1 will be y2.
Done.
Okay. You can till then try that, which I had given for you. E raised to sine inverse. Okay, so this will be 1 plus x square u into derivative of v. So there is no square and all. Straight away, this is only y1 plain. So this will become y2. Okay, plus v into derivative of u. This is anyways coefficient m. Derivative of y will become y1. Now, if you see, they have taken common. So bring this m y1 this side and take y1 common and write the answer. So m y1 I brought on the other side, so it became minus. If y is equal to sine inverse of x, the whole square, prove that 1 minus x square into y2 This will be y is equal to sine inverse x the whole square. Now differentiate. So when you differentiate, this is like something raised to square. So this will be y1. Now it's like x square. So derivative of that will be first 2x into derivative of what is inside the bracket. So that will be, okay. Now directly you cannot substitute this as y because this was square and there's no square here. Okay. There's a root sign. So what you do first, square on both sides. So when you square on both the sides, what you will get is y1 square, 2 square will become 4. All the terms will get squared up. Sine inverse of x, the whole square. 1 square will be anyways 1. And root will go and become, okay. And now if you see, this is equal to y. So from 1, instead of sine inverse of x square, put y in the next step. And then take 1 minus x square on the other side and differentiate. So this was the question given. Assume it to be, if this was not there, square was not there, straight away answer would have been 1 upon this. But because there's a square, you have to follow as something square. So x raised to square. So 2x into then derivative of this. Then root, if it is there, I have squared it. And then all the terms got squared. And now replace this by y. And 1 minus x square, I'll take it this side. So it will look like this. It is not, don't write y square, huh? It is y. This, the whole square is equal to single y. Okay, so this is what you will get the equation as. And now differentiate. This will be u and this will be v. So u into derivative. See, if this was y1, answer would have been y2, but this is square now. So that's why first what it will be, 2y1, derivative of y square will be 2y into extra derivative of this. That will be y2. There is no square and also straight away derivative of y1 will, y will be y1. Plus v into u I did not do. This is there, no? U into derivative of v plus v into derivative of u. I did only u into derivative of v. This I had not written. Plus v into derivative of u. And then common, divide by 2y1 and write the answer. So the answer will be 1 minus x square. Just see if I had given the same one. y1 is equal to 2. Once you're finished, you can try this. Y is equal, if y is equal to tan inverse x the whole square, two x into that side it is not clear because of the light. Just this is 2x, okay, x square plus 1 into y is equal to 2. y1 it is, huh? Anyways, if it's not there also, you will get the answer then finally. Is equal to 2 it is, huh? Same like previous problem, you have to square here also. Tell you why. Even though there's no root sign, still you square it. So first time when you differentiate, so it will be y1, tan something the whole square. So 2 tan inverse x raised to 1 into derivative of tan inverse of x. Okay, but there is a tan inverse of x here and there it is whole square. I directly cannot substitute. So what I'll do, even though there's no root sign, I want to get rid of this. So still you square it. So that when it becomes the whole square, you can put that value as y. So now what will happen over here? Y, the whole 2 will become 4. This is tan inverse x the whole square into, now there's no root sign. So what this will become? X square the whole square when you square it. And if you notice, see, here also in the answer also square is there. So anyways, when you square, all the terms will get squared. Then take this term this side. And this will become y. Now, instead of this, put y. This I'm bringing here. And now differentiate. So this will be u, entire thing. The other one will be v. Till here, any doubts, please ask. You can attempt and different start attempting. Even if it turns out wrong, no problem. Later you can change, cancel and write the correct one. Just try, don't wait till I solve. Just writing this step again. Huh? So when I differentiate, This is u, this is v. So u is what? 1 plus x square the whole square. This is u. V derivative I want to take. So something square is what? 2y1 first and then derivative of this. So that will be y2. Okay, then plus v into, now I want to take derivative of this. If square was not there, then straight away answer would have been what? 0 plus 2x. But this is square. Again, same like this. So first what will be the answer? This is like x square. So it will become 2x raised to 1 into derivative of what is the inside. So 0 plus 2x. And then 4y1. Okay, repeating again, u into derivative of v. Since it is like x square, it will be 2x into this plus this, and then you simplify it and divide with whatever is getting divided with. I think again divide by 2y1 only. Okay, so after dividing, we will get this. Okay, everywhere I have divided by 2y1. This is what you will get the answer. Only thing for this answer, they have written y1 this side. Okay, x they have written this side. So accordingly, you can arrange, no problem. So 11. Okay, y is equal to x plus root of x square minus 1 raised to m, and prove that x square minus 1 into y2 plus xy1 is equal to m square y. Now the given question is x. So now if you see, if you directly go to differentiate, now there's a power here. Okay. Now what will happen? This will become m something raised to x plus this x minus 1 raised to m minus 1 into derivative of what is the inside. That will become complicated. Okay. So what you can do is you can get rid of this power by taking log on both the sides. So taking log on both sides. So when you take log, what will happen? This will become log y, and this will become log of this raised to m. So m can be brought out. So you will get this step. Like this. And then power you can bring out. Okay. And now you can differentiate. There is no power involved now. M is like a pure number, so there is no u into v. Straight away log of this, log of this. So log of y will be what? 1 upon y into derivative. Extra derivative of y will be y1 or dy by dx. Same it is. Instead of dy by dx, you can write it as y1. So what I've done is taken log on both the sides. Okay, and now I'm differentiating. So derivative of log something will be 1 upon y, but this is not x. So extra derivative of y will be how much? y1 or dy by dx. We used to earlier write like this now, 1 by y, dy by dx. So it is same thing. So instead of dy by dx, I can write it as y1, which is equal to m is like a pure number, so keep him at the side only. So log of that will be 1 upon this into derivative of this. So derivative of x will be nothing but 1 plus root of something is what? 1 upon 2 root x square minus 1 into derivative of what is there inside the bracket. See, again I'm repeating, log of x. Log of x is nothing but 1 upon x. But this is not pure x. This is some complicated function. So I have to take derivative of this. So derivative of this will be, derivative of x is 1. Derivative of root of something is always 1 upon 2 root that into extra derivative is what inside the root. So that is 2x minus 0. When you minus 0 means what will remain is 2x only. So x and x will cancel. Sorry, 2 and 2 will cancel. Okay. So this will be 1 upon y into y1. Like this only. Now so what we will get is like this. And now cross multiply this. One plus x upon this you will get from this step. Now cross multiply. And then the numerator will cancel with this whole thing. So it will go. So this is when you cross multiply, you'll get like this. And if you notice, these two terms are same, x plus this, so this whole thing will cancel. So what will be left is, can write like this also. Okay, and then don't keep anything at the denominator. So what will happen? This will go up, and this from the denominator will go this side. So it will come up, and this will go this side, and then you can square to get rid of this. If you don't want to square, directly use this as u into v also and solve. Same answer you'll get. So squaring, this root will go, all the terms will get squared, and then you differentiate it for the second time. So I've taken derivative of log y, it is 1 upon y into y1, then taken log of this whole thing, 1 upon that into derivative of this. So when you take derivative of this, again this will be derivative of x is 1, derivative of this is this. Again extra derivative, what is inside the bracket. Then I've cross multiplied, and numerator and denominator turns out to be same. Both are plus. So cancel. Then this is left. So I've not kept anything at the denominator. Taken numerator, this one's denominator will go this side. And now square. So after squaring, we will get this term, x square, y1 square, m square, y square. And now I will differentiate. So this will be x square minus 1. So derivative of y1 square will be 2y1 into extra derivative of y1 will be y2 plus v into derivative of this 2x minus 0 m square. Derivative of y square will be first 2y into y1. Okay, u into derivative of v. So y1 square will be 2y1 into y2. Then simplify, divide by 2y1. And you should get the answer, whatever is told. Divide throughout by 2y1. So 2y1, so only xy will remain. M square y. So everywhere remove 2y1. Here also 2 will go, 1y1 will go. So only 1 will be left. Here 2y1 will go, only y will be left. Okay. And the last one. Last one for today's class. Huh? There will be more problems on this high order derivatives. If y into root of x square plus 1 is equal to log of prove that x square plus 1 d square y here there will d square y upon dx square. Same thing, it means what? Nothing but y2, and this is nothing but like y1. Okay, so we'll write the question. Now already there's a log, so you cannot take again log. So what you have to do, directly start differentiating. This will be what? U, and this will be like V. Now even there's a root, don't go to square, because again log of something, the whole square will become complicated. Straight away use this as U, and this will be V, and differentiate. So this will be U into derivative of V. Now root of something is what? 1 upon 2 root into derivative of this inside the bracket plus V into derivative of U. So this now what they are using, either you can write y as y1 or dy by dx. See, if you are comfortable now with y1, you can follow the same thing y1, and last you can change the answer. After getting y2, instead of y2, you can just replace it by d square y upon dx square. If you are comfortable like this with plain numbers, directly you can follow that only. So derivative of y will be what? y1 is equal to log of something. So that would be, here I'll write is equal to 1 upon into derivative of this. So 1 upon into 2x minus 1. I'll repeat this step. This is u into derivative of v. So y I've written as it is into derivative of root of something. So root of something is 1 upon 2 root something into extra derivative of this. So that is 2x plus 0 plus v into derivative of u. So derivative of y will be y1 is equal to log of something. So log of something is what? 1 upon that into derivative of this part I have to find now. So derivative of root is same like this one. 1 upon this into 2x minus derivative of x is what? 1. 2 and 2 will cancel, and then cross multiply like the previous problem. Take this root this side, cross multiply. Here also 2 and 2 will cancel, no? So x will get multiplied to y. Okay, so this is this term plus is equal to into cross multiply. So x minus So you'll get like this. After cross multiplying this term, you will get like this. Now can I directly cancel previous problem both? If this both were plus, then no problem because a plus b is same as b plus a. But now if you notice this sign, this is ulta, although same terms. This is in the form of like a minus b and this is b minus a. So first I'll have to change the sign. I want to reverse this. So what I'll have to do, take out minus common. So when I take out minus 1 common, this will become ulta. Okay. Anytime you want to reverse the terms, take out minus common, reverse the terms. And now you can cancel with this. If you directly cancel, you will miss out this minus. Huh? So you will get this xy upon okay. And now I want to get rid of this denominator. So multiply throughout by root of x square plus 1. So multiply all the terms with root of x square plus 1. So what will happen? Denominator will go. Root of x square plus 1 into root of x square plus 1 will give you just x square plus 1. Here also, if you multiply x square plus 1, only minus 1 will remain. Something I missed out. No, correct it is. Okay, so this is what you will get after simplifying. All the terms I multiplied by this. So actually what happens when I multiply like this and this will cancel and I'll get x into y. Okay, that part I have not shown. Again, if I multiply this, root and root will go and it will become single term. When you multiply here, root, this will cancel, only minus 1 will remain. And now you differentiate again. Why? Because second, you have still found out only y1. Now you have to find y2. This is just dy by dx. So second time you have to differentiate. And then you will get the answer. So when you differentiate, this is u into v. So x into y1, derivative of u, derivative of x will be 1. Same way, see this is u, this is v. Same way again, this is u and this is v. Derivative of y1 will be y2. Derivative of this will be 2x plus 0. And derivative of minus 1 will be 0 because it is a constant. So u into v here, u into v here. So total 4 terms you will get. How I got this? X is u into derivative of y will be y1 plus v I have written as it is. Derivative of x is 1. So x y1 plus y is equal to 0. And then arrange whatever, however same. What is happening? This is also 2x. So this is nothing but 1. If nothing is there, coefficient means 1. So 2 plus 1 will give you 3. So I'll write this term first. Okay. Then 2 plus 1 will give me 3. So we'll get this. Similar terms I've added. And now just write last, because they have said instead of y2 you can write d square y upon dx square. Instead of y you can simply write dy by dx is equal to 0. Even if you do like this, they will not cut marks. I follow this why, because it becomes difficult to write every time dy by dx, d square y upon dx. So this becomes easier. If you all want to follow like this throughout, no problem, you can. Whichever way you are comfortable. Okay. So we'll stop here. Wait a minute, I'll just take attendance. Okay. Okay, those are finished. Can leave the class. Any doubts? Then you can ask. Huh? Just practice these problems for tomorrow's class.